Imagine a world where a simple cut could kill. That was the reality before antibiotics. Infections, now easily treatable, were a death sentence. The discovery of penicillin in 1928 by Alexander Fleming marked a turning point, ushering in the era of antibiotics. This discovery, a true game-changer, revolutionized medicine and saved countless lives. It's hard to overstate the impact of antibiotics. They've transformed human health. Enter Alexander Fleming, a Scottish bacteriologist who stumbled upon a miracle. In 1928, while studying Staphylococcus bacteria, he noticed something peculiar in one of his Petri dishes. A mold had contaminated the dish, inhibiting the growth of the bacteria around it. Fleming's keen observation led to further investigation. He identified the mold as Penicillium notatum and discovered that it produced a substance that could kill bacteria. This substance, which he named penicillin, would soon change the world. Fleming published his findings in 1929. However, it wasn't until the early 1940s that penicillin's true potential was realized. The onset of World War II created an urgent need for effective treatments for infections. Fleming's keen observation and a bit of luck would change the course of medicine. Fleming wasn't exactly known for having the tidiest lab. In fact, his workspace was often cluttered with petri dishes, some forgotten for weeks. It was in one such dish, left unattended while Fleming was on vacation, that destiny intervened. Upon his return, Fleming noticed something unusual. A mold had taken root in a dish containing Staphylococcus bacteria, but what caught his eye was the clear zone surrounding the mold. The bacteria weren't growing near it. This chance observation, a result of both Fleming's forgetfulness and his scientific curiosity, would prove to be a pivotal moment in medical history. It highlighted the power of observation and the unexpected ways in which scientific breakthroughs. Penicillin works by targeting bacteria's ability to build their protective walls. Penicillin is like a demolition crew for bacteria. It targets their ability to build 𝚃𝙷𝙸𝙳𝙀, a crucial component of their cell walls. Without these walls, bacteria become vulnerable and eventually burst open. Imagine a building under construction. Penicillin acts like removing the scaffolding, leaving the structure weak and unable to stand. This mechanism makes penicillin particularly effective against a wide range of bacteria. The beauty of penicillin lies in its selective toxicity. It targets bacteria while leaving human cells unharmed. This is because human cells lack 𝚃𝙷𝙸𝙳𝙀, making penicillin a safe and effective treatment option. The challenge was to produce enough penicillin to meet the overwhelming demand. With penicillin's effectiveness proven, the next hurdle was mass production. The challenge was immense. Penicillin, in its initial form, was notoriously difficult to produce in large quantities. Scientists and industry experts joined forces, working tirelessly to develop efficient methods for penicillin production. They experimented with different fermentation techniques, eventually discovering a method using deep tank fermentation that allowed for large-scale production. This breakthrough paved the way for penicillin to be distributed widely. Hospitals across the globe received shipments of the life-saving drug, transforming the way bacterial infections were treated. Penicillin's success opened the floodgates for the discovery of new antibiotics. Penicillin's success ignited a revolution in medicine. Scientists, inspired by this breakthrough, intensified their search for new antibiotics, leading to the discovery of a whole arsenal of these life-saving drugs. Streptomycin, tetracycline, erythromycin, these were just some of the new antibiotics that emerged in the decades following penicillin's debut. These discoveries broadened the range of treatable bacterial infections, saving countless lives and revolutionizing healthcare. The antibiotic revolution marked a paradigm shift in medicine, giving healthcare professionals powerful tools to combat bacterial infections. This era witnessed a dramatic decline in deaths from infectious diseases, a testament to the profound impact of antibiotics. Penicillin remains a vital tool in our fight against bacterial infections. Over 90 years after its discovery, penicillin remains a cornerstone of modern medicine. Its effectiveness against a broad range of bacteria, coupled with its relatively low cost and minimal side effects, makes it an indispensable tool in the fight against infections. From treating ear infections in children to preventing infections after surgery, penicillin continues to play a vital role in healthcare settings worldwide. Its impact on global health, particularly in developing countries, is immeasurable. Penicillin's legacy extends beyond its direct medical applications. It serves as a reminder of the power of scientific curiosity, the importance of serendipity, and the profound impact that collaborative efforts between scientists and industry can have on human health. The fight against bacterial infections is far from over. While penicillin and other antibiotics have been incredibly successful, the fight against bacterial infections is far from over. The emergence of antibiotic resistance poses a significant threat to global health. Bacteria, being incredibly adaptable, can develop resistance to antibiotics over time. This resistance can render our current arsenal of antibiotics ineffective, leading to untreatable infections and increased mortality rates. Combating antibiotic resistance requires a multi-pronged approach. This includes developing new antibiotics, promoting responsible antibiotic use to prevent the emergence of resistance, and exploring alternative treatment options like phage therapy. The discovery of penicillin was a watershed moment in human history. It ushered in the antibiotic era, transforming medicine and saving countless lives. As we face the challenges of antibiotic resistance, it's crucial to remember the lessons learned from penicillin's discovery and to continue investing in research and innovation to stay one step ahead in the fight against bacterial infections.